So I have drawn all the circles with the points from 2 to 9, and I have made 3 generalizations about these. So my first one is when x and y are the same, then z is always the same. So we know that x is the number of points, we know y is the gap, and we know z is the number of times that the pen is lifted. So let's try some out. So I said when x and y are the same, then z will be the same as well. So let's go ahead and try with 2. So it's got 2 points, so we know that x is 2. The gap is 2. So it would be 2 because a gap of 2, we would end up back at this point, and then we'd have to lift the pen again to go ahead and do it with this point. So same with this one, gap of 3, we would end up there again, then we'd have to move the pen to here. Same thing with this one, so that's 3, 3, 3. With number 4, we know that there are 4 points, so x is 4. It's a gap of 4, so y would be 4 as well. Therefore, same thing, z would be 4 as well, and so on. And then my second generalization is when x is a prime number, z will always be 1, except when y equals x. So let's go ahead and attempt that with the first prime number, 2. So I said z will always be 1 except for when x equals y. So in this one we know that x and y are the same, so therefore z will not be 1. So in this one, x and y are not equal, so z is 1, because if we start here, a gap of 1, we'd end up here, we don't lift the pen, we continue. The next prime number, 3. In this one, x and y are the same, so that's why therefore z is not 1, but in these two, x and y are different, so z is 1 as well. So we'll go ahead and try this one, gap of 1. We will just draw a line there, there, there. We haven't lifted our pen. In this one, it's a gap of 2. So start here, we'll skip this one, we'll end there. And then again, we'll skip this one and we would end here. And then again, we would skip this one and we would end there. And we still haven't lifted our pen, so it's 1. So let's try with the next prime number, so 5. So let's try with a gap of 2. So we'll start here, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And we've ended up at the same point. We have not had to have to lift our pen. Same thing with gap of 1, 2, 3, 4, except for when it's x and y is the same. Let's try with 7 now, the next prime number. Same thing, so this one, x and y are the same, so that's 7. It's not 1, but the rest, 6, 5, 4, 3, 2, 1. Z is still always 1. So my third generalization is when y is a factor of x, then the pen is lifted m amount of times. So m equals the smallest factor of x and y besides 1. So let's go ahead and try some examples to see if it's correct. So let's start off with this one. So 4 points with a gap of 2. So we start off at this point, 1, 2, we'd end up there. Now if we keep going, we'd end up at the same point. So we need to lift our pen and start at this one. So 1, 2, And now we've reached all the points. So I said that x and y, z would be the smallest factor besides 1 of x and y. So out of 4 and 2, 2 is the smallest factor besides 1. So that proves that it's correct. Let's try another example. So let's try this one now. So 6 points with a gap of 2. So if we start here, 1, 2. So we'd go there, then there, then there. We'd end up at that point. Now we need to lift our pen again. Go there, 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 and then there. So x and y, 6 and 2. What's the smallest factor besides 1? 2. Now let's try another example. Now with the same amount of points, 6 points, but with a gap of 3. So this is what it would look like. X and y, what's the smallest factor besides 1? 3. Now let's try another one. So now this one, 8 points, gap of 2. It would look like this. We're lifting our pen now. X and y, 8 and 2. What's the smallest factor besides 1? 2. Now let's try another one. So we could do this one, 9 points with a gap of 3. So again, x and y, smallest factor besides 1 is 3.